All right, welcome into the daily question. Go ahead and get out a periodic table, preferably the AP Chemistry periodic table that you'll get on the AP exam, which looks like this. You can find at this link up here. And pause the video if you'd like to set a timer for about 1 minute and 30 seconds. Go ahead and do that and give this problem a try. I'm going to go ahead and go through the solution now.
Okay, so to find the empirical formula, we first have to determine the grams of all the elements in the compound. So we have an oxide of iron. So what that means is basically it's some sort of iron oxide. It contains iron and oxygen, which obviously we can see from the option choices as well, that those are the two elements and the only two elements in this compound. And they tell us that it's 70% Fe by mass, which obviously means that it's 30% oxygen by mass, since these are the only two elements in the compound. They need to add up to 100%. Now, we don't want just the percentages, we want the actual masses in grams, but that depends on like how big of a sample we have of this. So what we're going to do, and what you should always do when you're finding empirical formula, if they give you the percentages, is just arbitrarily assume a 100 gram sample. So if I have a 100 gram sample of this compound and 70% of its mass is iron, then I have 70 grams of iron. And I have 30 grams of oxygen. Now this is predicated on the assumption that it's a 100 gram sample, but it doesn't really matter the actual mass of the sample as long as you're consistent with all the elements. 100 grams is just an easy number to use because you don't actually have to change the number. Now we're going to convert each of these to moles, which you do by dividing by their respective molar masses. So get your periodic table out. Look at the molar masses of these elements. So iron, Fe, is 55.85. So we're going to divide by that 1 mole Fe over 55.85 grams. And then molar mass of oxygen is 16. 1 mole oxygen over 16 grams. So go ahead and do those calculations. If you haven't done this already, hopefully you've already given this a try, and hopefully you're doing this correctly. So this is about 1.25 roughly moles of Fe, and this is actually exactly 1.875 moles of oxygen. So we find the moles of each element, and then we're going to divide by the smallest number of moles. So the smallest number of moles here is the 1.25. So we'll divide this one by 1.25. That'll just give us 1. And then we'll divide this one by 1.25 as well. And that gives us about 1.5. So at this point, we're hoping that we get whole numbers, okay? Because we're trying to basically find the subscripts for each element. The subscripts have to be whole numbers. Now in some cases, you can round to the nearest whole number. If you get like 1.99, you can round that to 2, okay? But 1.5, can't round that to 2, can't round that to 1. That's not close enough. You should be generally within 0.05 of the nearest whole number to round to it, maybe 0.10, okay? But this is not nearly close enough to either 1 or 2 to round, but it is basically a clean fraction. This is 1.5. So then if you don't get a whole number or close enough to a whole number, but you do get a clean fraction or close to a clean fraction, then what you're going to do is you're going to basically multiply this by the smallest whole number necessary to make it a whole number. Okay, so 1.5. So let me just write this down here. So right now we're at Fe is a 1, oxygen's a 1.5. So I need to multiply this by 2. That's the smallest whole number that I can multiply this by to make it a whole number. That would make it 3. But if I multiply this by 2, then I also have to multiply this by 2. So this would be a 2. So these are our subscripts. So 2 is our subscript for Fe, 3 is our subscript for oxygen. So our empirical formula of this compound is Fe2O3.